Heyo everybody, before my fingers freeze, because the fire isn't really warm enough yet. Hi! And can you get a peek at the lake? I don't know. You see it right through there? Where am I trying to? Right through there. Okay. That's my panning shot. Also a log. I have a log for my, like, that's why it's that. Okay. Yeah, it's on a log. It's just a log. Hasn't been split yet. Okay, so let us talk a little bit about order of operation, okay? We should talk about operations and not just the game, which was fun when I was a kid. Okay, so there is essentially one operation, and it's the only operation that we ever really do, and that's adding. We're counting. We're counting up, which we call adding. We're counting backwards, which we call subtracting. We're counting in batches, which we call multiplication. We take away in batches, which we call division. We count in batches of batches, which we call exponents. We take away in batches of batches, which we call roots. So we do those things because they're easier, but they're still just counting. So we need to just learn what is 1 and 1. Well, 1 and 1 is 2, right? Okay? So again, this is order. Now, when I was a little kid, I remember I was a small child, and I started counting one afternoon because I didn't have the internet. I didn't go outside. My sister was probably reading a book, and my brother was probably learning how to be potty trained. Not sure. But I decided to count to infinity. And I got to about 1,000 before I realized I could be counting for the rest of my life and never end. And that was actually a seminal moment for me in math, because I actually sat there and counted for like an hour. And that's when I realized, like, why am I doing this? So, let's talk about adding, okay? Now, likely your child or you, hi children, learned this thing. I'm putting it in quotes because it's, okay, PEMDAS or PEMDAS for orders of operation, okay? I like to, if anything, I call it PEMA, because in my world, subtraction and division don't exist. Neither do roots. They're just exponents, multiplication, or addition in reverse. But it really, everything is this. That's why it's the last, because it's the base for everything, okay? So let's think about this for a second. We're 3 minutes in. I'm going to go right to 10, okay? 1 plus 1 equals 2. 1 plus 1 plus 1 equals 3, right? 1 plus 1 plus 1 plus 1 equals 4. I could just keep doing that forever. So I go, well, let's skip count, right? This is when we start to begin to learn multiplication tables, right? Okay, well, I'm going to skip count now. Every child gets really excited when they learn how to skip count because it's fun and you feel smart because you are. Okay, so we're going to count by twos. 2 plus 2 equals 4. 2 plus 2 plus 2 equals 6. Okay, all right, okay. I'm getting a little, I gotta wipe this off because I'm already getting bored because I'm already seeing the patterns and, like, don't waste my time. I'm smart. All right, hold on. I'm going to wipe my board. I got to wipe off my board. This is high tech. Okay. There's no wipe swipe. There's no delete button. There's no back refresh. It's just good old-fashioned dry erase. And you know what? Yeah, I'm using a blanket. Okay. Actually, sorry, Mom. She's the one who cares. Okay. So here's the thing. Are we ready? I could be using chalk. I mean, that's how I grew up. I don't know why I said that. Okay. So we're going to skip count. And what do we call this? We start calling this a multiplication table, don't we? Myself. Okay, so if I'm counting once, 1, 2, 3, 4, 5, 6, so on, right? Now I'm going to count twos. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12, and so on. Now I'm going to count by threes. And just in case I forget, I'm going to make 3 little dots over there. 3 plus 3 is 3, 4, 5, 6, 7, 8, 9. We're back to the ladybug picnic. 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on. Now I'm going to count by fours. Now I have to remember my dots. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and so on and so forth. And what's beautiful about mathematics is you might start to recognize that the columns are the same as the rows, right? And then we call these perfect squares, which we're going to get to in a second. So what I would challenge everyone on, okay, before we start getting into what multiplication is, and even what subtraction is, get yourself down with your counting, with your addition. Just add by 1. Just count. Just count, okay? So do a times table, but don't use your calculator. Do not use that completely defeats the point. I know a calculator can do this. You know a calculator can do this, but a calculator is only as smart as the people who program it. Tell that to my students who don't know how to factor and they don't know what factoring is, and I say, well, whoever told you to use a calculator, they kind of, don't do it. Don't get yourself in that place. Your brain is the strongest thing you have. Okay? So, no calculator. So, as a lesson, I would say get out a grid. 12 by 12 is the best. Everyone should have up to 12s memorized by 7th grade. Full stop. My son hates this, but it's true. You actually should have this memorized by 4th. That's the reality, but we can play catch up. Okay? 7th grade. That's the goal. If you don't get there by 7th grade, it's totally fine. But this should always be your goal, up to 12s. And if you're really savvy, you can go to 15s. Have it memorized. Okay? So what you do, any sheet of paper can do. You do not need an app. You do not need fancy things. You just need a piece of paper and some grids. And you just count. And then when you've done the whole thing, then you start to look for patterns. Hold on. There's 12, and there's 12, and there's 12. 24. If you kept going, you'd see a lot of 24s. The number you're going to find the most of is 60. So, stay safe, stay warm. My fingers are cold. And thank your math teacher. Have a good one.